In 1993, three men were cleaning a residential well in Maryland. Once they had pumped out most of the water, two of the men lowered the third into the well. The man began shoveling the muck out of the bottom and brushing down the sides. After about an hour, one of the men yelled down to the co-worker in the well, but didn't get an answer.
Jack, are you all right?
One of the men told the homeowner to call 911, and then the two went back and lowered another worker down on a board. The man found his co-worker barely conscious. He picked the man up, and the two men above ground started to hoist them to safety using the same board the rescuers used to lower the second worker. The board started to break, so they lowered the men back down and waited for rescue personnel. When rescue workers arrived, they threw a rope down to the two men, but both were too dazed to do anything with it. And by this time, the water level was rising again, and both men were treading water. A volunteer fireman went into the well and managed to get a rescue line around the second worker, who was by now unconscious. Attempts to revive him were unsuccessful, and the man was pronounced dead. The first victim was submerged, and when he was finally pulled out of the well, he too was pronounced dead. In Georgia, in 1986, 4 workers were cleaning a large wastewater holding tank at a chicken hatchery. After they removed the liquid waste using a vacuum hose, one of the men entered the tank to loosen the sludge at the bottom of the tank. When the man fell unconscious, one co-worker went in after him while another went for help. When he returned to the tank, he found that all 3 of his co-workers were inside the tank and unconscious. He followed, but also lost consciousness soon after entering. By the time rescue workers arrived and pulled the men out, 2 were dead and 2 were in critical condition. One of the 2 later died, bringing the death toll for the accident to 3. Incidents like these are all too common for workers operating in confined spaces. These victims probably didn't realize exactly how hazardous their jobs were. They may not have understood the risks they took, risks that led to their tragic deaths. In this program, we'll investigate these accidents to learn how they could have been prevented. We'll also explain how to safely work in confined spaces where, whether you know it or not, your life can be at risk. All confined spaces have some things in common. They all have limited openings for getting in and getting out, and are big enough for a person to enter, but are never intended for continuous occupancy. There are all kinds of confined spaces. Let's look at a few examples and see how each satisfies the 3-part definition of a confined space. A sewer system is a confined space. To enter, you usually have to go down a manhole. That's the limited opening for entry and exit. It also has poor natural ventilation. That, combined with the gases common to sewer systems, can make a work environment where it's impossible to breathe without appropriate respiratory protection. And sewers aren't intended for continuous human occupancy. That satisfies the 3rd part of the definition. Another example of a confined space is a grain silo. Silos have small openings at the top and bottom for entering and exiting. Ventilation is poor, and like in most confined spaces, deadly gases can be trapped inside, making breathing difficult. Silos are made for holding grains and other materials. They're not made to contain people for extended periods of time. Some other examples of confined spaces include storage tanks, compartments of ships, wells, digesters, degreasers, reaction vessels, boilers, ventilation and exhaust ducts, tunnels, underground utility vaults, and pipelines. When an accident occurs, we use a process called incident investigation to determine what went wrong so we can prevent it from ever happening again. In any incident, finding out what went wrong is the key to avoiding the same tragedy in the future. And even in near misses where no one is actually hurt, an incident investigation can avoid a future tragedy. Near misses are free warnings, but only if the incidents are reported, investigated, and acted on. The basic question to ask in an incident investigation is a simple one. Why did it happen? The answer may not be so simple, though, because there are many factors that can play a part in an incident. Start with what you know. For instance, we have an injured worker or a fatality. Continue to ask why. Why? Keep asking why until there are no more questions to ask. The ultimate goal is to find the root cause, the original error or errors that, when corrected, will keep the same thing from happening again. Following an accident or even a near miss, the 4 areas to investigate are people. Why were workers there in the first place? Were they properly trained? Were they following proper procedures? Equipment. Were the correct tools, materials, and equipment available and being used as intended? Were the tools in good condition? Was the correct personal protective equipment, or PPE, being used? Work environment. What about the work environment? Consider the layout and environmental conditions. What were the working conditions, such as oxygen levels, at the time of the incident? Did the layout or design of the area contribute to the incident? Management systems. What management systems were supposed to be in place to detect or correct the unsafe acts and conditions prior to entry? In this case, did the facility have a comprehensive confined space entry permit system? In any accident, there are 3 levels of causes. Level 1, direct causes. When you hear about an accident, this usually is all you hear about. For example, a man was on a ladder. One of the rungs broke. He fell and died. The level 1 cause of the fatality was the fall, but there's always more to the story as we dig deeper. Level 2, indirect causes. These are the unsafe actions or conditions that took place or existed before the accident itself. In the ladder example, the ladder was in disrepair and the man didn't check it closely before climbing down. Even still, though, we can investigate further. Level 3, root causes. These are what we call the management or process system failures that allowed the unsafe acts or conditions to exist. In this case, let's say we investigated and found that the ladders on this job site are improperly stored, which led to the damage to the ladder. And say we also determined through our investigation that both the man and his supervisor had noticed the damaged ladder in the past, but never got around to having it fixed. These are system failures which, if corrected, would not only have saved the man's life, but will prevent a repeat of the same tragedy. If you work in confined spaces, never underestimate the dangers of your work environment. Death can occur due to suffocation, explosion of flammable gases or combustible dusts, being engulfed in materials such as grain in a silo, electrocution, drowning, or losing consciousness and falling. To keep you safe on the job, the Occupational Safety and Health Administration, or OSHA, requires that your employer have a comprehensive confined space permit system, which should identify and evaluate permit space hazards, develop procedures and practices for safe entry, provide for proper equipment and use, test for acceptable atmosphere, establish procedures for emergency response, train all entrants, attendants, and the entry supervisor. Common hazards may include a hazardous atmosphere. The air inside the space is or could become dangerous. a potential to engulf an entrant. Small particles or liquids in the space could bury or drown you. A configuration that could trap an entrant. Maybe the floor slopes or walls converge inwardly, or there's an overhanging edge. Any other serious safety or health hazards. The space might have machinery that could start up unexpectedly, electricity, or extreme heat or cold. Test the air quality using approved equipment. You cannot see or smell many harmful gases, and you cannot determine how much oxygen is in the air without the proper equipment. Opening a confined space and sticking your head in is called breaking the plane of the opening. It can be fatal. You could be overcome by toxic gases, lose consciousness, fall into the space, and suffocate. Or, if fluids are present, you could drown. Ventilate confined spaces. Never ventilate a confined space with pure oxygen. It could result in a flammable gas mixture. Instead, be sure the space is ventilated with a properly configured ventilation system, which might include a fan or air mover. Then, retest air quality before entering the confined space. The system should assure an acceptable atmosphere for safe entry, but you may need to continue to ventilate the area as you work, since even your breathing could result in a lack of oxygen and too much carbon dioxide, which is what we exhale when we breathe. Isolate confined spaces before working in them. This means you take the space out of service, and there are 4 ways to do this. Locking out electrical sources, preferably at electrical disconnects located away from the equipment. Blanking and bleeding pneumatic, hydraulic, process, and utility lines. Disconnecting belt and chain drives and mechanical linkages on shaft-driven equipment, such as degreasers. Securing mechanical moving parts within confined spaces, using latches, chains, chocks, blocks, or other devices of the proper size and materials of construction. Use proper protective gear, including respiratory protection when required. There are 2 types of respiratory protection. Make sure you use the correct type. Air purifying respirators. These can protect you from harmful gases, vapors, dusts, mists, and fumes in confined spaces where there is also enough oxygen to breathe safely. Air supplying respirators. These are connected to sources of air and must be used in confined spaces where the oxygen level is below 19.5%. A respirator that includes an air supply that you carry on your back is called a self-contained breathing apparatus, or SCBA. These are commonly used by firefighters. Given the size, SCBAs are not always practical in a confined space. In that case, use an air-supplied unit with an escape bottle when entering confined spaces. Have a properly trained and equipped rescue person at the ready. This means there should be a plan in place in case of an accident for a rescue crew to get to the site within minutes. The team should also have training in the space you'll be working in. Whenever you're going into a confined space, make sure an attendant on the outside is in constant contact with you. The attendant's whole job is to maintain communication with the person inside the confined space and get help if needed. The standby person should never go into the confined space until rescue help arrives with proper equipment. More than half of all deaths in confined spaces occur when someone unprepared goes in to help a downed coworker. Evaluate all possible hazards before entering. These may include temperature extremes. If a space has just been steam cleaned, allow it to cool down before entering. Engulfment hazards. Silos are particularly dangerous when it comes to being engulfed. You can be pulled down and buried within seconds if you're standing on the surface inside a grain silo, for example. Noise. Excessive noise can not only cause permanent hearing loss, but it can prevent you from hearing shouted warnings from coworkers. Slick or wet surfaces. falling objects, the hazards of work performed, such as welding, burning, cutting, application of protective coatings, use of solvents, and cleaning materials. All these pre-entry preparations are entered on the confined space permit. The names of all entrants, attendants, and the supervisor are also listed. The results of the gas tests are listed, and you have a right to witness the gas testing or request additional testing if you believe it's necessary. Never enter a permit space unless the permit is complete and signed off. Now we'll investigate the two accidents described at the beginning of this video to determine what went wrong and how the accidents could have been avoided. In the accident in the well, in which both the original victim and the man who went in to rescue him died, we first ask why the men were in the well in the first place. That part is easy. A man had to go down into the well to clean it. But why did he lose consciousness? Because there was carbon monoxide in the well and not enough oxygen. The air we breathe is roughly made up of 21% oxygen, 78% nitrogen, and 1% argon. The key here is the oxygen. A person can survive if the air around him contains as little as 17% oxygen. But you should wear an air-supplying respirator if the oxygen level is below 19.5%. If the oxygen level goes down to 16% or less, your life is in danger. First, you lose muscle coordination. Your heart rate increases. You feel tired, and your breathing slows down. If the oxygen level goes below 10%, you start vomiting. Then you lose consciousness. Death can occur within minutes as your brain is starved of the oxygen it needs to function. Investigators found that the oxygen level in the well was between 12 and 15%. That, combined with the presence of carbon monoxide, made both men disoriented and unable to help each other. Ultimately, they both drowned after losing consciousness. How could this tragedy have been avoided? Several ways. First, if the workers had tested the well's atmosphere before entering, they would have learned that there wasn't enough oxygen down there for them to survive. But the first man in the well still could have completed the job safely if he had used an approved air-supplying respirator. If the men had been wearing harnesses and lifelines, they could have been pulled out of the well when they got into trouble. When vertical entry is being made, a mechanical retrieval device is required. It can be a portable unit brought to the site or a fixed unit. To summarize the investigation into the accident at the well, we determined the level 1 or direct cause of the accident to be drowning. Both men died after losing consciousness in the water. The level 2 or indirect cause was that both men went into the well without the proper protective or safety equipment and without testing the air quality in the well first. And the level 3, or root cause of the accident, was the lack of a comprehensive confined space entry permit system. Such a system would have ensured evaluation of space hazards, testing gases, a rescue plan in case of an accident, and training that would have alerted workers to the hazards of their work, how to use the right protective equipment, and how to be prepared for a rescue. If the company employing these men corrects these level 3 errors, the chance of another accident like the one that occurred is greatly reduced. In our second example at the chicken hatchery, our investigation reveals that the wastewater tank held various chemical cleaning agents from the plant, including ammonia, carbon dioxide, and residue from egg disinfectant. The workers did not test the air quality inside the tank before entering, so they didn't know that once inside, they wouldn't be able to breathe without respiratory protection. When the first worker went into the tank and started cleaning up the sludge, the cleaning process likely released more harmful gases into the air. One by one, Each man entered the tank to help his co-workers, but each fell victim to the toxic gases and became a victim himself. So, our investigation reveals the following. The level 1, or direct cause of the men's deaths, was suffocation due to the presence of gases that displaced the oxygen the men needed to breathe. The level 2, or indirect cause, was the actual presence of those harmful gases due to the materials that were regularly sent into the tank. And the level 3, or root cause, was a lack of a comprehensive confined entry permit system that included training by the men's employer about the dangers of their job, use of a confined space permit, proper air quality testing, and the right PPE, such as respiratory protection. Explosions can occur inside confined spaces very easily. If the oxygen level is above 21% and flammable gas, vapor, or dust is present in the right mixture, all it takes is something to ignite it, like sparks from a power tool, and an explosion will occur. This is why the atmosphere in a confined space is tested and results entered on the permit before anyone enters a confined space. Since some gases are heavier than air and some are lighter, you should test the air at different levels within the confined space. Remember, it's your right to witness the gas test and request an additional test if you believe it's necessary. Working in confined spaces can be hazardous, but once aware of the dangers, you can watch out for them and avoid them. Don't become another statistic. Never ignore posted warnings on confined spaces. Always test before entry. Follow the entry permit system completely, including the exact PPE listed. The more you know about the hazards associated with working in confined spaces, the better your chances of survival. You owe it to yourself, your loved ones, and your coworkers to stay safe on the job.